CE paper 1. So question 17. So question 17, it is transformation. Okay. Question 17, it is transformation. So what are we supposed to know about transformation? So with mathematics paper 1, the transformation which is examinable are three major transformations, which is the first three, which is translation. We also have refraction and the rotation. So these are the three major ones which are examinable. And then if you interact or interrogate most of the paper 1, you find that translation and the rotation, they are the one which are very, very common. Translation and the rotation. So meaning that when you are revising on that day, you are preparing for paper 1, mathematics. Okay, on the part of transformation, concentrate on these three. Concentrate on either translation, refraction, and the rotation. Then you are home and dry. Okay, so let me try and sketch roughly, just a rough sketch of the question. Okay, of which we have the first triangle and the second triangle there. So remember, I'm just sketching. So refer to the question for you to get the actual information. Then from here, we have, this is a 2, this is -2. So I'll just indicate something which I need. Okay, of course, it is on a graph paper. That's the reason why I'm writing this to my dotted, so that we can appreciate the coordinates there. Okay, and then down here is -2. Then this is P, this is Q, like that. So what is the question saying? What is the question saying? Okay, I've actually seen your concern, guys. It's a network on my end. I'm coming. I've seen your concern. You are unable to see. Sorry for that. Sorry for that. Let me try again. This. Give me a feedback. Are you able to see the board? Give me a feedback. All right. Thank you very much. Okay. So this is a summary of the question. Remember, this is paper 1, transformation. So what is the question saying? Okay. So the question is saying that the diagram shows triangle P and Q. So indeed, in this diagram, we have P and Q. What else is the question saying? The question is saying, describe fully the single transformation which maps triangle P onto triangle Q. So in short, the question wants us to describe the transformation that will map this P into a Q. Okay? So what I'll do is, for the purpose of revising, since we are revising, I'll try and dig to give you some stakes in the bone. Okay? So here, remember I've said with paper 1, the types of transformation that are examinable are 3, which is translation, refraction, and rotation. So meaning that for us to describe, we first need to identify to say the transformation that maps triangle P to Q, it is either translation, refraction, or rotation. So we need to identify which transformation will map this triangle P to Q. So mean that we need to have that ability of identifying. So I'll explain in a nutshell the differences between refraction, rotation, and translation so that we can have an idea. Okay? So I'll start with refraction. Okay? I'm going to spend time. So this time which I'm going to spend to explain about this concept, hope you are going to benefit from it and get one or two. So I'll start with refraction. What are we supposed to know about refraction? Remember refraction, this is also the types of transformation. And by the way, these three types of transformation, they have got one similar features. The similar feature is that they map an object, okay, to its image while maintaining the size of the shape. The size of the shape remains the same, okay? But if we go to paper 2, where we also appreciate something like enlargement, shear, and stretch. These three types of transformation, when they map an object to its image, okay, the shape will actually be different. For enlargement, the shape will either be, for example, if this is an object, okay, if this is an object, for enlargement, it's either the object will be big, okay, or very small. That is the enlargement. For shear, for example, if this is the object will be tilted at an angle. So mean that we are going to have something like this. So this is just an example. Okay? For stretch, if this is an object, we can have something like this. Have you seen that? So meaning that these three, enlargement, shear, and stretch, the shape of the object and its image is totally different. But for these first three, which is translation, refraction, and rotation, the object and the image, they have the same shape. Okay? Remember, with transformation, we are talking about the branch of mathematics that will transform an object to its image following a certain operation or procedure. So the initial shape that we have is called an object. Now, that shape, when it's transformed, okay, the shape that we are going to have is called an image. I'm explaining this too so that you can understand when I mention this is an object, this is the image, so that we can have an idea to say an object is the initial shape that we have or that we had. Now, when we use a certain operation or procedure to have another shape from the object, that new shape is the one we are referring to as the image. The transformed shape is the one we are referring to as the image. So all in all, guys, I'm saying with mathematics paper 1, transformation, it's either a translation, refraction, and rotation. Most especially translation and the rotation. Okay? So these three, okay, remember I'm just concluding about my introduction here. These three I've said, the similarity or the similar feature which is there is that they have the same shape. The image and the object have the same shape. compared to enlargement, shear, and stretch, where the image and the object have different shapes. So the reason why I've explained about enlargement and shear and stretch, so that maybe I can arouse you to go to paper 2 transformation. Okay, so that you can check it out as well, because it comes under section B, mathematics. It's always there. And by the way, in a situation where the exam is very hard, the situation where the exam is very hard and you are dealing with the paper 2, do you know that choosing questions like transformation, questions like statistics, those they have got certain free marks. Certain free marks where you are just plotting, they will give you the coordinate of object A and object B. Then they'll tell you to plot on a graph paper. And then they'll give you maybe 2 marks. Again, they'll tell you to say another object, this, when it's being transformed, it will produce this image. The coordinate they will give you. Then they'll ask you to say plot. So just in case things are hard, deal with those. At least out of 12 marks, maybe you can get 5 or 6, which is better than getting completely 0. So these are the strategies that we need to consider, especially when we have maybe 4 weeks before the exam. We need to consider these things. But for now, we need to appreciate the concept. We need to appreciate the concept. We need to know the concept by heart so that we can enjoy the calculation. So please, those whom have maybe initiated something in terms of transformation, go ahead, find out about enlargement, find out about shear and stretch, which is section B, mathematics paper 2. Okay, so now let me come to paper 1, where I was explaining about the translation, refraction, and rotation, of which I've said these 3, the similarity which is there is that they both, all of them, okay, the shape of the image and the object are of the same size. Okay, I'm sure I've lamented there and we have gotten something. Now let me dig now into these 3, of which I'll start with the refraction. With refraction, I can remember my secondary teacher. My secondary teacher, when he introduced this subtopic called refraction, he told us to say, actually, this subtopic is most used by ladies, refraction. They normally apply it practically, the concept of refraction. How? You can agree with me to say every lady or every woman, they mostly move with a mirror. Okay, with a mirror. With guys, you may find that maybe a week or even a month can pass without looking at a mirror. But with ladies, they apply this concept of mathematics. Okay, so what is refraction saying? For you to have refraction, you need to have what we call a mirror line. Okay, in reality, this is just a mirror. Remember, I'm just explaining this concept in a nutshell so that we can appreciate it. Okay, we need to have a mirror line. Other than a mirror line, let me use a human being as an example. The way we take our mirror, okay? So mean that, for example, if this is us, okay? If this is a person, and guys, nika example, so don't laugh at my drawing. Ka example here, nika rough map. Ka example, just for illustration purposes. Let me do this. Let me do this. Okay, this is just an example. Okay, if this is a person, and then this is a mirror. Okay, so this person will be called an object. Okay, when a person looks himself or herself on the mirror, what that person will see on the mirror is what we are referring to as the image. Is what we are calling the image. So now my first question is, the image of this person, is it going to be behind the mirror or in front of the mirror or at the line of the mirror? What is your view? This is something that we do in reality. So is when we are looking at ourselves on a mirror, is our image behind the mirror, in front of the mirror, or at the line of the mirror? Let me get your views. Who can I point randomly? Madam Kachana, wrong time. What do you think, Madam Kachana?
So, long time, sir. How are you?
I'm all right, thank you.
Okay. So you're asking if the image will be in front or at the back. Now, when you look at the mirror, let me say I'm looking at the mirror now. Then it will be in front of me.
So is your image going to be in front of the mirror or behind the mirror?
Behind the mirror.
Behind the mirror. Okay. Let me also get something from Madam Grace. Did you have the same response, Madam Grace? Your hand was up?
Yes, there's the same behind the mirror.
Okay. Madam Grace, can I involve you in this discussion? Okay. I want us to have a
Yes.
discussion which will help us to understand this concept, if you don't mind, so that others they can hear and listen.
No, I don't.
Okay, so now check. If you have a mirror, you have a very big mirror with you, and you are seeing
Yes.
yourself.
Yes.
The image, indeed, it will be behind the mirror. How can we prove that concept? Just imagine you start running, moving away from the mirror. What will happen to your image as you are running away from the mirror? What will happen to your image, Madam Grace? What do you think?
You can start running away from the mirror. It means you start going behind.
Exactly. Even the image, it will start running behind away. I don't know whether you are able to visualize what I'm talking about, guys. Okay? If you have a big mirror, okay, and then you start moving, for example, you have a big mirror, you move 2 steps away from the mirror. Even your image, it will move 2 steps behind, away from the mirror. So those are the principles that we need to appreciate as far as reflection is concerned. So meaning that now, in terms of reflection, if this is the object, the image also, first of all, it will be exactly the same as the object. Okay? It will be exactly the same as the object, even facing each other. Okay? The object and the mirror, sorry, the object and the image, one, they will face each other under reflection. They will face each other. Apart from facing each other, we need to also appreciate to say the distance from the object and the mirror line should be equal to the distance between the mirror line and the object. For example, if you measure the distance from the head to the mirror line, this distance should also be equal to the distance of the mirror line to the head of the object. This distance need to be equal. So mean that if you move your head behind, even the image will move, even the head of the image, okay, it will go behind to observe this rule, okay, this principle. The distance of the hand here, even from here up to there, they need to be equal. And then this need to be 90 degrees. So this is just a nutshell about reflection. Very good principle that we need to appreciate. Hope you have an idea now. So now, if we go back to our question, okay, we have P and Q. Okay, we have P and Q. P, it is an object. Q, it is the image. Now my question is P and Q, these two shapes, are they facing each other? By facing each other, I mean, for example, the illustration which I've given you guys, okay, where you have the head, okay, or your eyes facing the eyes of your image. There's no way you're looking at the mirror and what is visible is your behind. No, there's no way. Ionishite mirror kubutukeyo. Then what is there? It's your behind. No, run away. But the principle of the mirror under reflection, okay? If at all what is facing the mirror, it's your face, then also the image should also, so the face of the image should also face the mirror. Now, if we do this two diagram here, are these shapes facing each other? What do you think? Let me get your views. P and Q, are they facing each other? Who can try? Yes, Madam Grace.
Yes, they are facing each other.
They are facing each
Yes.
other. Okay, not really. They are not facing each other. Because for them to face each other, if this is an object, then the image should also be like this. Have you seen it? Because this is the first coordinate. So the first coordinate of the object should also be the first coordinate of the image. So this is facing each other. Now, a situation where you have this, and then the other shape, comes like this. This is not facing each other. Have you seen that? This is not facing each other. So it's more like this is the front, this is the front, this area, this is the front. But with the image, you have the back. This back is the one which is on the first. Have you seen that? This is the situation that we have here on these two. I don't know whether you have an idea.
Seems that it's a little bit like special paper too, right?
Yes. Of course, we need just to understand this principle, the way we use the mirror. And if you want to understand this reflection, try to interrogate when you are interacting with a mirror. Try to move behind, your image will go behind. Why is it doing so? So that it maintains the equal distance from the object, okay? The distance from you and the mirror line should be equal to the distance between the mirror line and your image. Have you seen? So which is about the reflection. So mean that P and Q here is not a reflection. It's not a reflection. So let's go to translation and rotation. Okay. So now with translation and rotation, let me start with rotation. a message in the group. Okay, she said, "Sir, how can I respond?" Hmm? Guys, advise me. Someone has said in the group to say, "Sir, what's happening? I'm failing to join." What should I respond?
Try again.
Try again, okay. Okay, try again. Okay. Now respond, Madam. Thank you. Okay. So with rotation, what we need to know about rotation is that this is a part where we need to look for a compass. We need to have a compass. We need to have a protractor. So a rotation maps an object to its image in a circular form. In a circular form. So for example, if this is the image, okay? Sorry, if this is the object, okay? And then there is an aspect of rotation. If there's an aspect of rotation, what are we supposed to do? Just a minute. Madam Faustina, are you there? I think she's having a challenge with network, eh? Okay. So if this is the object, with rotation, we need to know three things, okay? We need to know one, the angle of rotation. Angle of rotation. Then two, we need to know the direction. Direction matters. In fact, these are the two main ones that we are supposed to know. Okay. Then the other one, however, it's a center of rotation. Center of rotation. So now, in an instance where you have been given this to be an object, then for example, the origin, it's a center of rotation. Okay. And then the angle of rotation, for example, it's 180 degrees. So it's a situation where you get your compass, okay? You stand at the origin, and then you stand here, and then you move it in a circular form, like that. Again, you stand here, you pick this radius, you move, like that. Again, you stand here, you move it like that. Okay? And then from there now, you measure a 180, a straight line. That will start from here, pass there, going there. So mean that this point on the object, it will be here. Have you seen? And also you do the same with this. You draw a straight line, okay? So mean that this point, it will be here. Then again, you do the same with this one. Mean that this point, it will be somewhere here. And then you connect. Of course, it's not looking exactly because remember, I'm just sketching. I'm just sketching. But when you have a compass, a ruler, and a protractor, you are able to do this and come up with the exact shape. So all in all, what are you supposed to do, or what are you supposed to know about rotation as far as paper 1 is concerned? Rotation deals with the movement of the object to its image in the circular manner. Now, if we come to this, okay? If we come to our question here, regardless of the center which we are going to pick here, okay? Regardless of the center that we are going to pick here, this cannot move in a circular form. It cannot move in the circular form. because as it moves in the circular form, remember, it will not be exactly as in form of the direction of the shape. So if this shape is like this, if the object is like this, then the image will not be like this if at all it's rotation, because it's more like the image is rotating. Okay, the image is rotating. So meaning that, for example, if this is the object, so the image will be rotating. So it will be moving like this. It will be rotating. Okay, like that. It will be rotating. So that's what is happening. So mean that this part here, this question here, it's also not a rotation. So mean that we can jump now to the last part, which is translation. So translation, the concept of translation. Translation moves the object to its image in a straight line. The way it is, for example, if this is the object, okay, depending with the translation vector, if this is the object, let me do this. Depending with the translation vector, it will move this object to its image in a straight line. So mean that the image can be here, like this. So this is how translation moves. Okay? Or in this way, depending with the shape and the translation vector. So mean that the image can be here. We use red, can be here, like this. Have you seen? Which is the same as this situation that we have here in the diagram. As you can see, it's more like we had something like this. So this is how it's moving. So this is a translation. So now remember, we are describing Fourier. So for us to describe fully, one, we need to state the type of transformation when you are describing. State the type of transformation. Secondly, state the translation vector. State the translation vector. If you want to describe the translation Fourier, the types of transformation Fourier under translation. So meaning that the major aim that we are supposed to do is to know the translation vector. We need to know how to calculate the translation vector. So how are we supposed to calculate the translation vector? So to calculate the translation vector, there is a formula that we need to appreciate. That says the coordinate of the object plus the translation vector, which is in the form of x, y, should be equal to the object of the image. So this is the formula. So this is the formula under translation. We need to appreciate it as far as translation is concerned. The coordinate of the object plus translation vector is equal to an image. So now, since we are looking for an image, then we'll just make, since we are looking for translation vector, we don't have a translation vector so that we can describe Fourier. Okay? Don't have a translation vector. So we can make translation vector the subject of the formula, where we will say translation vector is equal to image minus the object. Remember, these things which I'm saying, image minus object, these are just the coordinates. So meaning that we need to go back in the diagram, we pick one coordinate of the object and its corresponding coordinate of the image. So, for example, if you want, we can pick this coordinate. So this coordinate is moving hand in hand with this coordinate there. Have you seen? Or if you want, we can pick this coordinate, which is moving hand in hand with that coordinate there. Or if you want, you can use this coordinate, which is moving with that coordinate there. It's your choice to make. So now I'll take this, which is mapping that one there. So this, the first one here, it is -2, 2, which is the object. The image here, it is 4, -2. So that's the reason why you are being provided this question on an XY plane or graph paper, so that you can pick the coordinate easily. So let me plug in. So the image, let me do this. So the image we have said is 4, -2. In column vector, we write it as 4, -2 minus the object. We are saying the coordinate to pick -2, 2. So I'll write -2, 2. Then we just now simplify. Remember, as we are simplifying, what we are supposed to do is we say 4 minus -2. Okay? And then we say -2 minus -2. Like that. So this will give us, this is equal to, of course, let's simplify the negatives, where we'll say 4 plus 2, like that. Okay? And then, sorry, I've made a mistake here. I don't know whether you have seen. On 2, this 2, when writing it here, I've written it as a negative, but it's a positive here. So this is supposed to be a positive. So I'll remove the negative, this negative there. So this is just a 2. Okay? So mean that we have -2 minus 2, like that. Of which 4 plus 2 is 6. -2 minus 2 is -4. So this is the translation vector. This is the translation vector. So now let's describe the transformation fully. What are we supposed to do for us to describe the transformation fully? I've said 1, okay, state the type of transformation. 2, state the translation vector. So meaning that we'll say it is a translation. It is a translation with a translation vector, with a translation vector 6, -4. This is the answer that you are looking for. Remember, I've not cancelled this answer, no, just when underlining. So this is our final answer, like that. Okay. I know it's a bit tedious, most especially if at all this is your first time you are appreciating this concept. But of course, I'll share the video so that you can revise through and appreciate this concept. Okay. And let's see if at all there is a question at heart before I move to the next question. Any question? Yes, Mr. Tembo.
Yes, sir. I just wanted to know, how can you know the difference between an object and the image?
Okay. So with regard to that question, the good part is they will state it in the question. How are they going to state it? They will state it to say this object has been transformed to that object. For example, here is saying the diagram shows triangle P and Q. Describe fully the single transformation which maps triangle P onto triangle Q. Have you see? So a transformation that maps triangle P to triangle Q. So mean that P is the initial object which has been moved to Q. So P is the object, Q is the image. So the statement to be given to you in the question. Are you okay with that response, Mr. Tembo?
Yes, I'm okay now.
Wonderful. So to appreciate this, guys, look for paper 1, go to transformation. Try and do 1 or 2 from there so that you can appreciate it. Remember, transformation comes each and every year. I've never seen paper 1 without transformation. Okay, so let's move to question B. So question B is computer. Even computer mathematics comes very much examinable. We need to appreciate. So with this computer, it's saying in the answer space below is an incomplete flowchart for calculating the volume of a cone. Given the radius r and the height h of the cone, complete the flowchart. So you have been given the volume of a cone to be V is equal to 1 over 3 pi r squared h. So this is the formula. And then they want us to complete the flowchart, of which in this flowchart, first of all, they have given this. They have given us this. Okay. They have given us this shape. Okay. So before I solve, let me just try and interrogate. These shapes under computer mathematics, what we are supposed to know is to appreciate the shapes. We need to know the name of the shape. We also need to know what it means. So the first shape there on top, it's an oval. This is an oval shape. Okay. So an oval shape, what does it mean? Anyone with an idea? An oval shape, what does it mean? Yes, Madam Juanita?
It means begin or start.
Okay.
Or end or stop.
Yes. So meaning that oval, it's always start. Okay. In other books, they say begin. The same oval, if at all it comes at the end, it means stop. Okay? Or end. That's the reason why in the diagram, these things have been given to us already. They start and they stop. So always, when you are starting something, okay, or when you're doing something, you need to have a starting and the ending. So the shape is oval, always. Thereafter, we have a parallelogram, the second shape. So the second shape, it is a parallelogram. So remember, guys, this topic comes both in paper 1 and paper 2. Please, let's appreciate it. Comes in both paper 1 and paper 2. Parallelogram, what does it mean? Parallelogram. Namwali, what do you think? Do you have any idea? Yes, Namwali? I don't know whether it's a network. Mr. Tembo, do you have any idea what it means? Parallelogram?
No idea, sir.
Okay. Then let me explain. So parallelogram, as you can see, the second shape and the last second shape, it is a parallelogram. This shape means two. One, we are inserting. We need to insert. It is also an output. An output. Inserting is more like we are feeding our computer with data, with information. When we feed the computer with information, what we get, it is an output. In a layman's language, let me do this. I'm saying layman's language. Okay? Pakuteka pakawari, guys. Kuteka pakawari. Cooking shima. When cooking shima, first of all, of course, we need to start. The first thing, to start. Okay? After we start, what will happen? Okay? Remember, if at all we have millimil, water, okay? Then we have stove, okay? And a cooking stick, of course. Okay? So, under parallelogram, you just need to list things that you are supposed to have. Okay? Which is millimil, water, stove, cooking stick. Okay? Thereafter, we have another shape which is a rectangle. Rectangle, you are now processing. So in short, you are now cooking. The actual cooking is a rectangle. So in terms of formulas, that's why now you are calculating the actual value, doing the calculation here, or indicating the formula here. That's why you need to indicate the formula. After cooking, what happens is another parallelogram to show what? An output. To show number, akawarikadiredi. It's now shima. Okay? If at all maybe it's a mathematical question, after showing the formula here, and then you even put the values under the rectangle processing, under output, that's why now you show the actual value. Maybe volume is equal to 20 centimeters cubic, for example. Now, after an output, what happens? We end with an oval. You stop. So this is just a layman's explanation, which I'm trying to put up so that we can appreciate. And again, as we are writing these shapes, we need to show these arrows to show the direction. We start from this shape, go to another shape. Very important. Now let's come back here. And let's answer the question now. Hope the background information which I've given has helped. So now in this question, what they have done is they have given us a flowchart and they want us to find the volume using this formula here, which I've written. Using this formula here. Okay? And then, of course, they have also given other information like on the output here, they have just written output V, meaning that the value of the volume that we have calculated. Okay? And then we stop after that. So the question is saying, complete the flowchart. So we need to complete this flowchart. This we have been given, this we have been given, and this we have been given. So we need to put here and here. So mean that on the first parallelogram, we need to feed it data. What data? So now we'll say we need to enter, what are we going to enter? Radius and h, not pi. Pi is a constant value. So here just mention the letters which are part of the formula. So we'll say enter r comma, h. That's all. And then rectangle, we are now calculating, we are now cooking. That's why we need to show the full formula, where we say volume is equal to 1/3. Instead of showing pi, remember between 1/3 and pi, there's times. Even here, there's times. Even here, there's times. So those times, we need to show them by a star. That's a computer language. Star, pi. Again, star, another r, star, another r, because it's r squared. Star, h. Then we are done. Any question for me? Any question for me? Madam Grace, do you have any question for me?
No, sir.
All right, okay. I believe also to say we are just revising. I gave you this question so that you can go through for a purpose, so that as we are revising together now, we can now just cement our understanding. And also that question that you had in your heart, so that you can bring it, so that you can bring it out for clarification. Let's go to question 18. 18, which is the concept of variation. So 18. So 18 says z varies inversely as the square of x. Maybe let me write it first. Okay, or since we have the paper, since we have the question, I think I can just read it. Z varies inversely as the square of x, and directly as y. Okay? So z varies inversely. Okay, so here, let me do this. Let me write the important points. Okay? So we have z. This z varies inversely. Inversely as square of x, and then directly as y. So we need to write this into a mathematical language. So now we'll say z varies, so we'll show the proportional symbol inversely. Okay, at first I made a mistake actually. Inversely, it's 1/x. Okay, now since it's inversely square of x, so we'll say 1/x squared. Directly as y, so we'll say times y. So this is the same as z varies, then we say y over x squared. If we simplify, 1 times y is y over x squared. Let's see if there's a question here. Anyone with a question at this point? Anyone with a question? Okay. If there's no question, let's proceed. So now, when you are dealing with variation, when you reach this point, we need to remove this symbol, the proportional symbol, by putting an equal sign. So we say z is equal to, once you remove this, then put an equal sign, you need to introduce a constant k. Okay? So now we have k y over x squared. So this is just more like a rule that we need to appreciate. Once you remove the proportional symbol, you need to insert a k, like that. Okay. After doing this, question 1 is saying we need to find the value of k, the constant of variation. Okay. Where now we have been given to say, remember the statement was saying z varies inversely as the square of x and directly as y. Okay. And then now they have given to say z is equal to a 6 this information. X is equal to -3, y is equal to 27. So we need to find the value of k, which is the first question, which is the constant of variation. Okay. So to find the k, the constant of variation, where there is z, we shall put 6. Where there is k, is what we are looking for, times where there is y, we shall put what? 27. Because the value of y is 27, this value here. So we shall put 27 over x is -3. So -3 squared. So let's just continue simplifying here. We have 6 is equal to k times 27 is 27k over -3 squared is 9. Then we just need to cross multiply. 1 times 27k is 27k is equal to, of which now 9 times the 6, it's 54. 54. Then now we divide by 27, divide by 27. So we say k is equal to a 2, which is the value of k. So that's how we calculate the value of the constant. Okay. And then we go to question B. What is question B saying? Question B is saying we need to find the value of z when y is equal to -6 and x equal to -4. So with all the calculations that will follow now, B and C, remember we made this statement here, which I'll write here, where we are saying z is equal to ky over x squared. So now we say z is equal to k, we know the value that is 2. So we now substitute. Is 2y over x2. So now here they are saying we find z given y to be equal to -6 and x to be equal to -2. Okay, so we just need to substitute. So 2, the value of y is -6 over x is -2 squared, of which 2 times -6, the answer is -12 over -4 squared, the answer is a 4. So z is equal to 4 into -12, the answer is -3. So this is our final answer. Any question for me? Okay, if there's no question, let's move to the last question, which is question C. Question C, I said, remember for the question that follows, always we need to work with this, where you have substituted the value of z. So the value of k. So mean that it's z is equal to 2y over x squared. Okay, so in this question, they want us to find the value of x, where we have been given y to be 8, z to be 1. So we just need to substitute. Z is 1 is equal to 2 times 8 over x squared. Then we just cross multiply 1 times x squared. The answer is x squared. Okay, so write x squared is equal to, then 2 times 8, the answer is 16. To remain with y, we introduce square root. So now on the square root, this is where people lose marks. On the square root, people lose marks on the square root. I'm emphasizing. So on the square root, you need to introduce the positive or negative here. Positive or negative. Okay, so the square root and the square will cancel each other. So we are going to remain with x is equal to positive or negative. The square root of 16 is a 4. Like that. So this simply means that the value of x, will say x is equal to 4, or x is equal to -4, like that. So this is our final answer. And let's see if there's any question for me. Let's see if there's any question for me. Yes, Madam Grace.
Sir, can you solve this one without introducing the square root?
Okay. If you solve it without introducing the square root, you can lose a mark because you can only find the value of 4, where you enjoy it using indices. Okay? Where you can enjoy using the concept of indices, because where we will have x squared is equal to 16. Okay? We can say we'll introduce power half. Okay? Power half. Introduce power half, even here power half. So introduce power half both sides, of which power half, these 2 and these 2, they will cancel each other. So you remain with what? X is equal to, remember 16 is the same as 4 squared. 4 squared. But we also have times power half, of which with that power half, these 2 and these 2, they will cancel each other. These 2. So mean that we just remain with x is equal to 4. So now you have lost a mark on the negatives, because there's a rule that says that when you introduce the negative, you need also to add the positive or negative. However, this is another way. But under normal circumstances, anything raised to power half is the same as the square root. Are you okay with my response, Madam Grace? Thank you very much. All right, guys, I feel today we'll end from here. Let me not give you much info that you fail to revise at the end of the day, because I want you to spend time on transformation. Please try to challenge yourself. Spend time on transformation. Know those 3 types of transformation. Go to paper 2, the other 3 types of transformation, so that we can just see how they come. And even that part which I explained to say you can easily get marks just by plotting, that is under transformation. Okay, just plotting on the XY plane, there are marks there. And where you are lucky, they can go up to 5 or 6. Just plotting. So please, let's try to find time to do that. And let's see if at all there's any question for me. And then remember, I said Tuesday is just a cover up of Wednesday, which is tomorrow, because I might be committed. So tomorrow, I don't think we are going to have a lesson unless otherwise. Okay, so that's the reason why I pushed for today for us to do 1 or 2. Okay, guys, if at all, yes, Madam Grace.
Sir, also to yesterday's video and today's.
Okay, no, I will share it. I wanted to upload it today. Now, unfortunately, there was no power the whole day. Power came around 18:19. Now, I thought if I'm uploading while teaching, might experience bad network, because uploads I need a lot of network and enough bundles. But I will try to do that tonight. All right, sir. Thank you. All right, guys. I said right, sir. All right, guys. Thank you very much for joining. Have a good night. Please find time to revise those concepts that we have enjoyed. Okay, very important. Thank you very much, guys. Have a good night. Bye bye.